In this video, we will create a unique to-do application that makes use of our alligator friend over here to chomp away our chores. So this is making use of SwiftUI and Rive animations. So the alligator is a Rive animation, and as you can see, as you drag in the to-do item, the alligator comes in to chomp away the chore, but only if you actually reach a certain threshold, then the complete animation finishes. So yeah, in this video, I am going to show you exactly how you can create this animation. And maybe going swimming is not a good idea for this app, but learning some new SwiftUI 5 features, as that is what we will be using in this video. There's some nice new things they added to SwiftUI 5 that makes handling animations and also scroll views a lot better. And we'll be touching on those. And in this video, I'm going to show you start to finish how you can create this application, as well as taking a look at the underlying Rive animation, how you can remix a file, and how you can create quite a basic animation such as this easily, and then drive it using the Rive state machine. So with that said, let us get started with this video. Before we delve into the code, let's quickly explore the animation used in this example. This was inspired by something that Pedro made. He made this mock to-do application in Rive, and as you can see, as you swipe, the alligator comes up. And we'll be snipping out pieces of the animations used in this file and then recreating it in our SwiftUI application. But yeah, this is going to be the basis of our design and also, as you can see, the alligator animation. So if you are curious to see how this was made, you can go over to the Rive app community. The link for this will be in the video description, and you can remix the file and basically nip and tuck the pieces of the animation that you would like to use. And that is actually exactly what I did. I remixed Pedro's file and I deleted most of the example UI, and I just kept the alligator artboard. And additionally changed a little bit in the state machine and the animations. And we'll take a look at this when we get to that portion of the tutorial. But if we preview this now, you'll see that we have a scroll percentage here. And as you scroll, the alligator just bites. Eventually, if you reach a value of 100, it does the look animation. And there's also a continuous blink animation, which is a layer on the state machine. If this is unfamiliar to you, don't worry, we will take a look at this in more detail in a bit. A quick note before we get started, at the time of recording this video, Xcode 15 was still in beta, so that requires you to have Xcode 15 as a beta client installed. However, by the time you watch this video, it may be that Xcode 15 is already released. We will be using some SwiftUI 5 features that is not available in prior versions. But for the most part, you will be able to follow along with this tutorial. There's only some small code that we add at the end of the video. But yeah, please take notes if you want to install beta and follow along exactly. Okay, so let's start with the coding part. And I've created a new SwiftUI project. And the first thing that we'll do is we're going to add a new file. And this will be a SwiftUI view, and we will call this the to-do list. So that is the first component that we'll add. It's just the list of to-dos. Let's put in chomping chores, as that is going to be the title of our application. And we'll set the foreground color to be the accent color. And we will update the accent color in a moment. And we also can change the font to be a font.large. And we can also set the weight to be bold. Okay, so we're getting somewhere. We have our title. Next thing that we want to do is add a text title just below this. So we're actually just going to wrap this in a V-stack. So that's going to be a vertical stack. And just below this, we'll add a new text, and this will be scale today. Sorry for all of the puns. And again, this is going to be a foreground color, and this one we will actually set to be white, but we'll give it some opacity, and the opacity is going to be 0.6. And for now, we won't actually see it because it's white on a white background, but we'll change that in a moment. the fonts we can set to be sub headline. And for now, let's just give this a background color, and we can just say black. Sorry, this should just be background. And we will also give it a padding, and we'll say 8 for all around. And we can give it a corner radius after the background, and the corner radius can be 16. And finally, we can end with another padding. And now that we have some elements on screen, it's probably a good call for us to add the colors that we will need for our application. And instead of me just entering them manually, I am going to copy it over from a project I made before making this tutorial. And if you didn't know, you can easily copy paste these values from one Xcode project to another. So I'm just going to go into assets. I copied it from the previous project, Command C, and I'm just pressing Command V, and there we go. As you can see, it did make a slight mistake as I'm also copying the accent color. So if we delete the current accent color, and then we can just rename it to be not one, but accent color. Okay, and if we go back into our to-do list, one small mistake is I do want to have this underneath the Alligator to do demo folder. You can see that the accent color has now updated to that purple color. And you can get the final version of this project on GitHub, and there you can find all of the colors that we used. The next thing that we want to do is to add the field where we can enter our text and add a new component. And that's going to be within this VStack. However, we would need to also make that an HStack because it will have two components. The first will be a text field. So this will allow us to enter text, and we can give it a indicator of what it should contain. So for example, this would be the to-do item, and then we can also create a binding for the current text value. And this binding we would need to create as a state variable. So I'm just going to create that at the top here, and this will be add state, and we can call it private var new item title, and the initial value we will just set to be an empty string, and we can pass that in here. And important to create preface this with $, so that we create the binding. And in here you can now see we have the field. We actually cannot see the to do item because it is black on black, and instead of us using the black background that we already set, we can change that to one of the colors we declared. And I'm going to make this color, and the name for that is dark card. And we actually still can't see it. I'm not too sure why. I think it's just because the gray is not visible, but we actually don't want there to be any indicator of what this value is. For the UI that we're going with, this can be empty. And then after this, we can add a new button, and we will select the action option. Let's go with this. We don't need the title. I guess we can add the title, but we're going to customize the text value a little bit differently. So we'll keep this as is, and instead wrap it with a value, and that's going to be text, and we'll call it add. And we'll also style this slightly differently. So we'll give this a foreground color of accent color. We'll give it a font of headline, and we'll also bold that font, and we'll give it a padding, and the padding will be trailing as we only want the padding on the right side. And currently we are getting an error, and that's just because we need to add something over here. So I'm just going to add an empty callback for now. And as you can see, now we have the add button, and we have our text field over here. The text field is still a little bit cramped, so let's proceed to add a few extra things. We'll wrap it in a frame, we'll wrap it in a padding, and it's going to be only horizontal padding, so left and right. We'll also give it a text field style, and that style is going to be a plain text field style. And if we read what this is, a text field style with no decoration. Perfect. We don't want any other decoration. We want it to be simple. And then finally, we'll give a font, headline, and we can make this weight medium. And we'll also set the foreground color to be white, and we can give it a corner radius of 16. And now it doesn't look that much different, as the last thing that we need to add is an overlay that will give it a rounded rectangle. So we'll select overlay, and we will select the rounded rectangle option. And within that, we can give it a corner radius of 16. And now you can see we have a little bit more visual distinction. We'll give it a stroke, and the value can be white with an opacity of 0.2. And there we go. So now we have a rounded rectangle as a border. And I just realized that I should have increased the font so that it's a little bit easier to read. Okay, so the next thing that we can do is we can add a new empty method that we can just call for now within the action button. And at the bottom here, we'll create that. So I'm just going to create a new func, and we'll call this add item. And within this action, we'll call add item. And we'll keep it empty for now. But underneath all of this, we now need to add our list of items. This is where we will add our scroll view. So underneath this VStack, we will create a new scroll view. However, within the scroll view, we also need to wrap this in a VStack, because currently we get this generic parameter content can't be within that. So what we'll do is we're going to control click and say embed in VStack. So VStack inside a VStack. But just below the VStack we already have, this is where we will add the scroll view. And in the scroll view, we will need to loop over our to-do items, but currently we don't have that created yet. So we will create a new file, and that new file can just be a Swift file. And this will be called to-do item. Actually, no, this can be called to-do model, as that is what we are making. We are creating a model. And let's just drag that into the correct location. And this will be a struct of to-do model, and this will extend identifiable. And if we take a look at what identifiable is, a class of types whose instances hold the value of an entity with a stable identity. So this will allow us to use the for each on our list of to-do items to get the actual unique item in our list. And we will create some fields for this, and we will need an ID, which we can set to be a UUID. So this will be unique for each struct created. And we can also need a title, which is going to be the name of our to-do, which is going to be a value of string. And then is complete, which will be a Boolean to indicate if the to-do item is complete or not. And by default, when we create the struct, we will set the value to be false. So now if we jump back into to-do list, what we can do is we can create a new state field, also private, and we will call this to-do items. And this is going to be a type of list, which will take in a to-do model. And we can actually initialize this to be empty for now. And at the bottom, we will do for each, and we can pass in our to-do items. And let's just make this plural, to-do items. And for this, we get a to-do item in. For now, we can just say text to-do item dot title. And as you can see, we aren't seeing anything because our current list of to-do items is empty. So for that, we can just create our first to-do model. And we can say the title for this is test, and it will be default false. And technically now we should see it. There we go. I'm just going to copy in some mock data for us. So as you can see, we have 3 new models: Go Swimming, Make a To-Do List app, and Experiment with Rive. And we don't need that extra closing bracket. Okay, now we can actually add new to-do items within our add item function. So what we'll do is we'll do a check to see if the new item title is empty. So we'll actually saying we're negating it. So we're saying if it's not empty, then what we want to do is create a new string value for new item. Not a string value, sorry, a to-do model. And this will be to-do model. And the title is going to be the value of new item title. And what we'll do then is take our to-do items, so the list, and we will append our new item at the end. And then finally, we will say new item title equals an empty string. So whenever we call add item, we will first check to make sure it is actually has a value, that this text field is an empty. We'll create a new to-do model. We will append that model to the list of current models we have, which is the to-do items. And then we will make sure that the text field is set back to an empty value. So we can actually just test this now, and let's see if it works. We'll say, does it work? And it does, as you can see. One thing that would be nice is if we press enter, it automatically adds it for us as well. And that is something we can add within our text field. So just behind the text, we can say on commit, and we can call add item. So now if we type something and press enter, it adds it as well. Todo actually does not delete it, and I'll leave that as an exercise for you to figure out. Let's continue with the main tutorial. Okay, so currently it's not very exciting. We're just displaying some text every time in our scroll view. We'd like to make our code a little bit more readable and robust by extracting some of these views to their own unique views. So instead of just adding everything that we want to show in our to-do tile over here within this code, we will create a new view that will abstract all of that logic. So I'm going to create a new file, and this will be a SwiftUI view, and this will we can call to-do tile. And within this to-do tile, we will pass in a item, which is going to be our to-do model. And for now, let's just keep it the same. We will say title dot item dot title. And we can mock the value here by just passing in a value of item. So let's pass in a to-do model, title, and we can just say test. And here we need to pass in the name. Okay, so the preview is done, and as you can see, we have our value registered here. And then back in our to-do list, instead of us passing in a text value, we will say to-do item, and we pass in the item. And this doesn't need to be the title, it needs to be the complete to-do item. And this should be called to-do tile. Okay, so we're making progress. What we'll do now is just work within to-do tile. I'm just going to move this below to-do list. And within this, we'll need to add the logic for each of our tiles. And this is where the Rive animation will live, and where we will also be adding a lot of unique gesture handling. So to begin, let's start with the UI aspects of this. And we will wrap this text value in an H tag, and we'll call that the foreground color is going to be white, and we'll give it a font with a value of headline. And at the bottom of this H tag, we'll add padding, and we'll just say padding for all. Background, we can give it a color with the value of card. And just to remind you, these are the colors that we defined in our assets over here. And then below that, we can add corner radius of 16 and a shadow color first. We will say black, opacity of 0.2, and we can give it a radius. The radius can be 6, and then we'll just move it slightly to the right, and we can move it slightly down in the X and Y. And as you can see, we have a slight shadow there now. And if we hop on back to our to-do list, you can see it's starting to come along. Okay, let's just get this to a new line and select everything and say Control I, just to format it slightly differently. And after the shadow, we will add another padding. And this padding we will say is horizontal. And we shouldn't see any difference now, but this padding will be important in a little bit. And then just below this, this is where we're going to add our new gesture. So this is going to be using the modifier called gesture. And within this, we can create a new drag gesture. And this is where most of the magic will happen. And on this drag gesture, we will call onChanged. And with this, we will be able to get the value of the current drag that's happening. And for this, we will say value in. And what we can do for now is just print that value. So I'm just going to print the value. And for this, we will actually need to run our application just so that we can see the print value. And as you can see, it's still with hello world. We don't want that. Let's go to our content view. And instead of passing in all of these, I'm just going to say to-do list. And let's run our application again. Okay, and now you can see we are dragging, or I'm dragging, and you'll actually note that we are performing some prints if we inspect our console over here. So drag gesture value platform value this, we're printing something at least. Okay, so that means something is definitely working, but what we do want is to now use the value that we get from this drag gesture to update the offset of our to-do item. So let's get started with that. And we will create a new state variable. So we'll call this add state, and this is a var, and we'll say current drag offset, and this will be a CG float, and we will start it off by setting it equal to 0. And just below our padding over here, we will add a offset, and this will be in the X position, and we will say this is the current drag offset. So as an example, if we make this 100 and save, it offsets it by 100 pixels to the right. But we want it to start at 0, and instead, as we're dragging, we want to update the current drag offset. And we can do that within our onChange. So what we'll do is we'll say the current drag offset is equal to our value dot translation, and this value is what we're getting in from our gesture, and we will say that this should be equal to the width. So this is how far we've currently dragged. Now if we start dragging this, you can actually see it is moving, but it's a little bit stiff, and definitely doesn't feel Swifty or iOS-y. So what we can do is a quick fix is just to say with animation, and within this animation we will say we'll use a spring, and as a callback we can just set the current drag offset, and this will actually feel a lot better. As you can see, it has a little bit better movement now, but we do have the problem that as we're dragging it around, it's not shooting back to the start. Normally what we would want with this type of gesture is as you drag the item, it should shoot back. And we can easily do that by adding an onEnd. So after onChanged, we will say onEnded. And same thing for this, we can get a value in. And again, we will use with animation. And this will also be a spring. And at the end of this, we will say that the current drag offset should be back at 0. And now if we test it out, you can see it shoots back as soon as you let go of the drag. A small UI component that we're missing is that the to-do item should take up more of the screen. Currently it's just taking up the size of the text that is in the view. We would like it to expand to be as large as possible. So within our H tag, just below the text, we will add a spacer. And now it takes up all the remaining available space. And as you can see, we are starting to get somewhere with our swiping action. And just to preview what this looks like in our to-do list, it's looking good. While we are in this to-do list view, let's actually just add a few extra elements to make this visually stand out more. So we're going to add a background, and this is going to be our gradient background. So we'll say that this is a linear gradient, and we'll pass in a gradient. And here we need to specify the colors that we want to pass in, along with the starting and ending points. So the starting points we would want to be the top, and the end point we will set to be the bottom. And we will need 3 different colors. yeah, okay, let's remove that gradient and we'll pass in the colors. And I'm just going to quickly fill in these colors and speed that up. Okay, now we have a nice linear gradient background. Another thing to add is with the background of the dark card color, so this over here, this is a little bit sharp, so let's just say opacity 0.8. And once you actually run this on a real app, you'll see there's a little bit more of a fade as well, so you can see the linear gradients in the background. And for the text field that we have, we're just going to wrap that in another padding as well. And just leave it empty, just so there's a bit more space. And I think this is starting to look good. We're finally at the most fun part of the project, and that's going to be to add our Rive animation. So to do that, we need to go into File, and we can say Add Package Dependency. And have this as recently used, but you can search for the GitHub URL, so Rive app / Rive iOS. And we will select up to next major version, which is at the time of recording this video 5.1.6 to 6.0. So anything within this version range should be working for you if you want to follow exactly. You can also take a look at the documentation for migration guides if you need to. If you go over to Rive's documentation, you will see that there is documentation for all of our runtimes, including iOS and Mac, with additional instructions on how to add Rive to your project and everything you need to get up and running. Additionally, you'll see that there is documentation such as animation playback, layout, state machines, text, and these provide additional information on editor-specific things you might want to integrate in your runtime. For example, updating Rive text at runtime, or for example, interacting with a state machine. We will see some state machine integration in this video, but if you need more information, do check out the docs for additional examples. So back in SwiftUI, we will select Rive iOS, and I'm going to add that as a package. And then add package, and let's open up our file inspector over here. What we can do now is add our animation to our project. Within the editor, we can go over here to share, download for runtime. And I'm going to explain more of the animation in a moment as soon as we get to that portion of the video. For now, we just want to get the file. So if you select for runtime, it will download it. I've already done that. And here's the downloaded file. I'm just going to drag that into our application over here. You can create this or add this to a folder as well if you need to. Just important to select add to target, and you select the target apps you want to add it to. Okay, so now we have our animation file, and in the to-do tile, what we'll do is we'll import the Rive runtime, and the Rive runtime works by creating a Rive to-do model. So for that, we will create a new state object, which will be an instance of the Rive model, and we'll just call this view model, or we can call this Rive model to make it a little bit more clear, and we'll instantiate Rive model, and this requires us to pass in a file name, and for this you need to give the name of the file, and this needs to be spelled correctly. So this is called alligator swipe, and you do not need to give the extension. There is an option to pass in the extension as is. By default, it is set to .riv or .riv. And we can also give it a fit. So we will say, for now, just .fit. Actually, we'll say .contain. And within our view, we are going to return that. So for now, let's see what it looks like by adding it between the text and the spacer. I'm going to say Rive view model, and I'm just going to call .view on that. And if we refresh this, we should see our animation now. And there we go. Here we have our alligator, and he is standing completely still, except for the fact that he's blinking. And this will actually be a little bit clearer once we delve into how we interact with the animation and why he's blinking and nothing else is moving. So we actually do not want to display this animation here. What we instead want is for the animation to be as an overlay. And we can do that at the bottom of everything that we have here. So at the bottom of this H tag, after all of these modifiers, so after the gesture as well, we will add dot overlay, and within this overlay, we can add our animation. So now you can see it is looking somewhat more correct, except it's really small. So let's start by resizing this slightly. We will give it a frame, and we will set the width, and we want the width to be equal to the screen width. And for this, we will actually create a new field because we will be using this in a different place as well. So just below state object, let's create a new field called screen width, and this will be the UI screen dot main dot bounds dot width. So this will give you the exact width of the emulator or device, and we can pass that in here. And the height we will set to be equal to 250. Okay, so now you can see we have our alligator friend, and he's a lot bigger, but he's not exactly aligned where we want him to be. And this can be a combination of either modifying your frame. So in your Rive file, when you go to the design mode and you select your frame, you have the option to specify a height and width for this, and maybe repositioning the element. Or of course, you can also do this through code. So I'm just going to opt for that, and we are going to give this an offset, which is going to be a permanent offset. For now, we'll say that x0 and y we will say as -25. And this -25 just moved them up slightly, and I can see he's more aligned with the actual to-do item that he needs to chomp down. But we do have a problem. Currently, as we're like dragging around, I can't click the to-do item, I can't drag it. And that is because the Rive view is actually absorbing our pointer. Because our Rive animation file can have listeners attached to it that intercept certain mouse events or touch events. And you can create buttons in Rive as an example. But we, in this instance, don't want that to happen. We will actually want to pass through our touch actions to the element that's below it. And we can easily do that in SwiftUI. We can just say allows hit testing, and we'll set that to be false. And now we can actually drag our elements again. So the Rive view is no longer absorbing the hits. Okay, but now what we need to do is we want the inverse of what's currently happening. Our alligator friend is currently showing up on screen, but we want him visible, and we only want to show him once we start the drag. So as we're dragging to the right, he should be coming in from the left. You'll also note that we have a little bit of an edge there, like a little bit of the white showing. And again, we can fix this in the animation file, or if you want to do the lazy programmer route, I'm just going to shift him off by 2 pixels to the right. So now we no longer see that white piece at the end. Very scientific, and it's working. But as I was saying, we want it hidden. So we'll start off by giving a x value, which is going to be the screen width. And now he's gone. But if we say screen width -10, maybe -20, 50, here he's coming in. So as we are increasing this value, he's slowly, reaching closer and closer and starting to eat the to-do item. And that is technically what we want to do, is we want to now offset his position by some value. And we have this with the current drag offset. So if we say negative current drag offset, let's see what happens. That's working. It looks like something is happening. It's not exactly right. We would maybe want him to come in a little bit further. So to make this a little bit simpler, and also because we need to, because later on you'll see why, we're going to create another field. So we're going to go to the top here where we have current drag offsets, and we're going to create, I'm just going to copy all of this, and we're going to create 2 new ones. One will be the alligator drag offset, and the other one will be the ending drag offset. And all of them will start off at 0. And again, not very scientific, but for the purpose of this demo, we'll do it like this. Within our animation that we are updating the current drag offset, we're just going to update the alligator drag offset as well. And this is going to be the value translation with exactly the same, but we're going to multiply it by 1.9. And the reason for that is because we want the alligator drag offset to just happen a little bit more than what we're dragging here. Here we're dragging it slowly and the alligator is coming in slowly, but we want the alligator to be coming in a little bit faster. And this is something you can obviously experiment with. Maybe it should be dependent on the size of the screen. Yeah, there's some factors at play here. But instead of using the current drag offset, we'll use the alligator drag offset. And now if we drag it in, you can see he's coming out a lot more. A little bit too much, actually, but we'll fix that in a moment. The other problem is if we let go now, he's not bouncing back. And that is because we will obviously need to tell him to go back. So alligator drag offset in the on-ended call, we will set that back to 0. And as you can see, he snaps back. But there's still some things to fix. He's, for one, going too far, but we'll get to that. What we want to do now is let him chomp. So as we are moving this, he needs to slowly move his state machine input value to chomp down. And if we go to the animation file and go to animate tab, let's just move my head, play, and you can see we have this value of 59. This should actually be starting at 0. But if we move this slowly up, eventually he'll start chomping down. And the reason it takes a while for him to chomp down is because that's how I set up the animation. So there's multiple animations we have here. The simplest one is blink. If we play this, you can see as it reaches those keyframes, the alligator blinks. And this is a span of 3 seconds. And in our state machine, we have a blink layer, and we go from entry into our blink state, which is a looping animation as set up here. So it's not one shot, it is loop. And that means that as long as we play this, the character will continuously blink each 3 seconds. And if you wanted to add more variety in that, probably some things you can do there. But for now, this character is quite simple. He's just blinking every 3 seconds. And in our layer over here, what we're doing is a few things. Let's just zoom in. From entry, we are transitioning into a blend. And the blend that we're transitioning into takes in our scroll input and determines the 2 animation timelines to blend between. So we have our base animation state, which doesn't do anything. This just resets the crocodile to this current value over here. If we play this animation, absolutely nothing happens. It just resets the all of the keys and the colors. In this instance, no colors, but all of the positions and bones to be in the exact correct position. But if we take a look at the croc over here, here we have a bite. Let's move this. You can see he bites. And this is going to be what we actually want to animate. But we do want to animate that not just by calling animation.play. We want that animation to happen as we adjust the scroll value. And the scroll value can be a value between 0 and 100. And if we take a look at this blend, this is where this input comes into play. And we are blending 2 different animations, the base and the croc. And we are only blending it from 40 to 100. So between the value of 0 to 40, it's going to play the base. From 40 to 60, 40 to 100, it will play a blend between base and croc. And as an example, if we were to change this to 0 and play the animation, and now you can see he immediately starts biting up until 100. And when it reaches 100, we transition into finish. And you can see here we have conditions within this transition. So once scroll is more than 100, or equal to more than 100, then it transitions into the finish animation. And the finish animation is exactly that. The alligator just looks at you. It just moves the alligator's pupils to look at you. And the reason that in this blend I'm using 40 to 100 is because I don't want the alligator to immediately start chomping. Again, you can modify this with code. There's lots of ways you could have approached this. I just opted in for the easier animation fix where I only want the chomping to happen once the percentage is more than 40%. So this will make sense if we take a look at the code. What we'll do is we're going to create some new fields over here and set the state machine input value to be the percentage of the chomp as you drag this over here. And for that, we will create a new percentage variable, and this is going to be the value of the translation dot width divided by the screen width. And here I'm multiplying it by 150. And this is kind of arbitrary. It just makes the chomp happen even more. And this was just like me experimenting with it to get it correctly. Again, you can modify this within your animation file or make the code slightly more elegant. For now, if we wanted to leave the 150, let's just do 100, and I'll show you what it is. This will give us a value between 0 and 100, depending on the width that we've dragged and the screen width. Okay, so let's say we've done 10 pixels and the screen width is 200, then that means we've done 5%. And we multiply it by 100 so that it's not 0.05, it's 5%. Okay, and then we want to update the actual alligator. And by updating the alligator, I mean updating the state machine input. So at the top here, let's create a new func, and we'll call this update alligator. And this takes in a value of type double. And for this, we will say the Rive view model, and we'll call set input. And the input that we will set is scroll, and we will set it equal to the value that we pass in. And just to make sure you understand, the input value here is called scroll, and this is a value of type double. And here the name needs to be exact to find the correct value to set. And yeah, we're setting the scroll. Important to note is that something I didn't touch on is within the Rive view model, you have the option to specify a few other things. You can specify the artboard name, the state machine name, but we're not doing that in this instance because this artboard or this file has a single artboard and it has a single state machine on that artboard, which means the Rive runtime will use the only artboard it finds, or the default artboard and the default state machine, or the only artboard and the only state machine. So we didn't need to specify it in this file or in this instance, but see the documentation for iOS if you run into issues where you need to load a particular artboard or state machine. Yeah, we're updating the alligator's set input. So what we can do now is underneath here, we can call update alligator and we'll pass in the percentage. Okay, and now if we start dragging, you can see eventually the alligator starts biting. So me fooling around with the animation values, maybe it makes sense for the alligator to start biting earlier and not when we reach, a value of 40%. But this is where I did that slight hack and just said multiply by 150, just so the bite happens a little bit sooner. And there we go. Now he's biting in a way that as we reach the end here, it kind of looks like the alligator is eating it actually. And as you can see, it's really easy to set a state machine input. But there is some stuff that's not exactly correct. For one, we can drag left, which doesn't feel right, like we can drag left too far. So to quickly fix this, I'm going to say if the value.translation.width is smaller than -30, I'm just going to immediately return. So now, as soon as you get -30, it returns. So you can't swipe left anymore. You can only swipe right. And the other problem is that we can definitely swipe too far along. That's also not correct. So let's take a look at what we should do to resolve that. We would want to introduce some form of max drag. So like we can't drag further than a certain value. So let's create that new field. And we can call that max drag, and we'll set that to be equal to 200. And just below this with animation, we will say if the value dot translation dot width is bigger than max drag, then we will say with animation, and we'll give a spring value, and we will say the current drag offset is 0. The ending drag offset is going to be the screen width. And you might have forgotten what the ending drag offset is because we haven't used it. I've only declared it. And the alligator drag offset is going to be the max drag times 1.9. And we will see why. So the reason it's 1.9 is because we offset the alligator drag offset by 1.9 just to make it move a little bit faster. So we want to do this here as well. And this is where a little bit of the magic happens. We're setting the current drag offset back to 0 because we don't want to let that have an impact anymore. Instead, we want to set some ending drag offset so that it remains consistent throughout the animations or the rest of the interactions that may happen. And to do that, we will add a new offset just at the bottom here. So here we have current drag offset. This is going to be 0 after we reach that point. But now we just want to set it to be the ending drag offset, which will have some consistent fixed value, which is going to be the screen width. So if we take a look now, it should be better. You can see the animation finishes there, and it actually doesn't move further along. So as I'm moving my mouse, it does stop there. But what we'd like now is some concept of whether the drag has completed or not, because we need some additional checks just to make sure our animation behaves correctly. If you were to, like, for example, move your mouse back. So like if I'm moving here, it should be completed. I shouldn't be able to go left anymore, because at this point the animation is or the to-do item should be triggered. You shouldn't be able to go back anymore. The alligator has eaten it, if you will. And for that, we will do some additional checks. We'll need a new variable. So I'm just going to create a new state var called isCompleted, and we'll set that equal to be false for the start. This needs to be at. We will say func complete. So we'll call this method when everything completes, and we'll say isCompleted equals true, and we'll call update alligator to be 100. So regardless of scrolling, we always want to make sure that our alligator is at a value of 100 when complete is called. That's just an extra safety check to make sure that things are correct. And then we will do the following. We'll say with animation, we'll say spring, and we'll add a delay of 1 second. And at the end of this, we will say that the alligator drag offset should be 0. And it shouldn't be X, it should just be alligator drag offset. So what's happening here is when we call the complete method, we set isComplete to true. We make sure that our state machine is updated to be 100 for our input. And then we wait 1 second, and then we animate the alligator drag offset off screen. So where do we call this complete? We would need to call it in this drag gesture. So if the value, the translation.width is bigger than max drag, then we can call complete. And let's see what happens here. If I remember correctly, I think this should actually result in like some very weird logic. If we move it now, oh, it actually works okay. What we do want to do though, is we want to add another check here, just to make sure that if we are complete, so if we are complete, or if it's less than 30, so if we're swiping left, then immediately return. There's no reason for us to do any additional calculation at this stage. And also within this on end, so when the drag ends, we don't immediately want to set the alligator drag offset to 0. We only want to do it if is completed, if we're not completed. So we only want to send the alligator back if it's not completed and we let go. Otherwise, if it is completed, we don't want the alligator to move back immediately. Instead, we want it to happen within this complete. So after a delay of 1 second, then we will finally call that. So let's just preview our animation and make sure it works correctly. So as we move, he bites. If we let go, he moves. We can't go left. Eventually, if we go all the way right, he will trigger his animation to look at you and then wait 1 second and then he will go back. Okay, so this seems to be everything that we need. The thing that we're missing though is in our to-do list, how do we know when an animation completes? Also, you'll note that, oh, we have a problem. We can't actually see our alligator friend at the top here. And this is something that SwiftUI 5 makes really easy for us with scroll views. And the rest of this video is actually going to be nice SwiftUI features that we can talk about. So let's start with the problem of knowing when a to-do tile is finished. So like when the swiping has completed. And to do that, we will pass in a onComplete callback. And what this callback gets is the to-do model. And this will be of type void. And this will require us to pass that in. So onComplete, and we get in the to-do item in. Let's just say print delete. Okay, it may be giving issues because in to-do list, we need to pass it in as well. Okay, so for here, we can say onComplete, and here we will actually create a new method called delete item, and we get in our item, which is of type to-do model, and here we can just pass in that. So yeah, let's just do it like this. That's fine. And we don't want to specify the name. Okay, going back into our to-do tile, we need to call this onComplete. And this is a nice SwiftUI 5 feature. When we call complete, we want the animation to show for 1 second before we actually delete the item. So let me show you what happens if we don't do what SwiftUI 5 allows us to do. I'm just going to call onComplete and pass in our item. I think that's what we called it. Yeah, item. So let's just see what it looks like in our to-do list. I'm going to swipe. And it's not doing anything. And that's because I haven't deleted it. So what we can do is find the correct item to delete and delete it. And we're going to do that with just some code I'm going to paste in. So what we're doing is we're finding the index. So we're looking for all of our to-do items, finding the first index where the item value and the ID of the index matches. And we get that index, and if it exists, then we call to-do items remove at index. Okay, if we now play this again and swipe, it's still not doing anything, which is quite odd. Now I'm actually a little bit confused. Let's make sure that we are calling the actual field. We'll go back into to-do tile, and yep, we have onComplete. What happens if we call this before with animation? Okay, so now it seems to do what I wanted to demo. If we swipe now, you can see the moment onComplete gets called, the to-do item is deleted, and we no longer have that nice exit transition for our alligator. And I think it just needed some refresh. If we do move this down here as well, it would happen as well, as far as I know. Let's go in and swipe. You can see it immediately deletes it. What we do want is we want to use a new thing that SwiftUI 5 gives us, and that allows us to know when with animation completes. And to do that, we just say completion and move our onComplete there and pass in our item. So now this will only get called once the animation is complete. Now if we swipe, you can see the animation still happens. Though, as you just noticed, we still have this problem where it's clipping our animation in our scroll view. And this is another nice SwiftUI 5 feature. Basically, it improves a lot of different functionalities around, wrong place, should be in to-do list. Yeah, a lot of different functionality within scroll view. And one such is to disable clipping. So we'll add a modifier and we'll say scroll clip disabled. And now if we run it, you can see it is no longer clipping at the top. It is, however, looking like it's doing something odd at the bottom, but it's actually not. It's just that because we're using overlays and using our to-do items like this, it's just rendering one to-do item on top of the other one. I kind of like this. It looks like he's swimming in water. For example, if you were to do at the bottom, it doesn't show. But if you add a new to-do and do it here, then again, it's rendering above it. But I kind of like the aesthetic. And I think that's basically that. We can run our animation on an actual emulator and just see that it is working as intended. And yeah, it seems to be deleting and it seems to be eating. I do believe that is that for this video. We definitely did some hacks to get things working. There's a lot of optimizations we can do to make this better, at least from like not using random numbers to multiply things. Additionally, something you can consider is to conditionally render your Rive animations. So currently we are displaying our Rive animations for each of these to-do items. So each time you do this, it is creating a new view, and it's basically recreating all of these resources each time. A better way might be to instead keep track of the position of where you are on screen and have one animation layered over the whole view, and then, you know, just showing the alligator at the correct position in the to-do list instead of using it in each of the to-do items. Something else you could do is you could conditionally render your animation or disable it. So let's actually try that real quick. In our to-do tile, where we do this overlay, we can say that if the alligator drag offset, let's say if is bigger than 0, and yeah, we'll add that. And let's play our animation. Okay, and now it is still working, but you'll see very interestingly, it fades away if you don't, if you let go. But it now will actually only show the Rive animation once you start dragging. And it clearly doesn't work that great just adding that flag, because it will eventually remove it. But of course you can do something else where you maybe have an additional boolean over here to indicate if the drag has started or not. So maybe like a conditional, the first time you drag, it will start rendering it, and that will be maybe set back to false when you know the animation is either complete or you know that the alligator should not be visible. So there's some optimizations you can do in that regard. But yeah, with that said, I do think that is the end of this video. If you have questions, you can reach out to us on Discord. We'd be happy to answer any questions you may have. Until the next video, bye-bye.